So in English, I assume. So, as already said, I'm from the company LTH Baas. I'm a naval architect, and actually I'm also working as a head of estimation department. And I am more focused on technical projects, estimation of technical projects. So, as I assume most of you know, LTH Baas is a fully Estonian-owned company. It's a family business. The company was already founded 1934. And this company have like two legs. We are involved with new building projects, shipbuilding projects, and also retrofit and modernization projects. And we are operating worldwide. So who are our people? Today, we have approximately 700 workers, including office team and onboard, installation team. We have our own engineering department, procurement department, logistics department, HR department, and of course project management department, including the project managers and supervisors. Plus, of course, our own workers, pipe fitters, electricians, steel fitters, welders, and maybe something that makes LTH a little bit unique in this business is that we are mainly using our own workers, so that all these, let's say, 700 people, and especially hard worker people like welders, pipe fitters, they are on LTH payroll. But of course, sometimes we need very specific skills. As an example, sometimes we need divers to do some underwater works. Of course, then we hire this company. And we have very good relationship with one of Estonian divers company who have helped us actually worldwide. We have used their services in Malta, Barcelona, Norway, in Italy. So everything is actually possible. And there is very high competence in Estonia regarding diving works. LTH headquarters is located in Tallinn, where we have, let's say, our R&D, design, project management team, logistics center, and also we are mainly using workshop located in Estonia for, the steel works. Plus, LTH also have site offices, mainly in Europe, in the biggest shipbuilding yards in Germany, and also in Italy, as you can see on this site. And also we have a sales and project support located in Miami, in US. We have participated in dry docking operations worldwide, Asia, Europe, North America. Plus, we are doing projects worldwide in operation, and actually this is the main field, or let's say the main activity that LTH is doing. LTH is doing projects in operation, when the ship is operating at sea. And we are mainly working in cruise ship industry, so we are doing these projects on board cruise ships, all these large cruise liners as NCL, Royal Caribbean, MSC, Disney, all of them are our clients. And yes, and as you can also see on this slide. Plus, we have business relationships with big players, the equipment providers as ABB, Wärtsilä, Valmet. Yes, and also in addition to ship owners, some main shipyards where we are working are also mentioned on this slide. So, what kind of projects LTH is involved? I have divided, let's say, the projects between small and large, plus simple projects, and also between small, large, and complex projects. So what's the difference? The difference is that there is like a risk and profit. You can see this axis. When we are talking about small but simple projects, then actually these are not very interesting for LTH, because LTH is a very big company. 700 plus workers. This number is again increasing. Before COVID, we had 1,200 workers, but because of this COVID reason, so this number was dropped. But now we are also growing fast. And let's say our organization is maybe too big. I mean, the management is just too big to do the small projects. But at the same time, you need to do small projects. Because all these small projects, if you are doing these projects properly, then actually you learn something from these projects. And these small projects helps you to make a step to the next level. You convince, let's say, the ship owner also that you know what you are doing, and also the ship owner is willing to give you larger projects, which is also at the same time, let's say, need more competence to do this. And doing such a way, actually, by the end of the day, if you have done these small projects in a proper way, then actually, most probably, the ship owner is willing to give you a big project, a big piece of cake. But there is a risk if you take this big project, because if you don't know still what you are doing, let's say the ship owner overestimates your skills and your knowledge, then actually, instead of earning money, you can burn the money. So actually, you need to think before you accept the challenge. As Alunaut, I think, gentleman also said that we several times we think that we will take this fund from or not, so you need to think. But if you have a strong team, if the company is in a good position in terms of financial terms, and you have, like I said, a strong team who is willing to accept the challenge, then actually you should take the challenge. And actually, LTH is interested to do the projects which are large, but at the same time also complex, because not every company is able to do these projects. Because, okay, everybody can accept the challenge, but by the end of the day, maybe you're burning money, not earning money. So, and if you're talking about big, large projects which are also complex, then actually first you need to think what you are doing. So it means that you need to have balls, but you should not be stupid. And once you accept the challenge, then of course the next step is to prepare the quotation. But when you are preparing the quotation, then also you need to understand exactly, and your sales team need to understand exactly what exactly you are offering to your client. So you should not make promises that later project management team cannot do. And for that purpose, in every larger projects, LTH sales team involves also estimation department. There are also engineers, and I am also the naval architect, so I have a very good understanding and a wide view of different kind of technical projects. So because I'm also, in addition that I'm preparing the quotations, I also usually will visit the ship when the ship, there is the larger project, so I will constantly receive the feedback from the project management team, what went wrong, what was underestimated, what, let's say, need to be improved in the future. So keep your promises and understand what exactly you are promising. So once, let's say, the client accepts your quotation and you are asked to meet with them to, let's say, discuss your quotation, then actually this is, at least for me, this is the most interesting task, because you are sitting next to the table where are you, and also the ship owner. And let's say what is the task from the ship owner side is to reduce the price as much as possible. They just want to squeeze you. And then you need to find the ways how to protect your offer. So you must have very good knowledge and competence to be able to defend your quotation. And actually I enjoy this ride very much. And if you are able to defend your quotation, then actually you can earn quite good money. But of course, to earn the good money, then you need to still understand what you are doing, because you can agree very good terms for the company. But if the project management team, starting from the engineering side, don't know what we are doing, then actually you can burn the money that you can potentially earn. And on this graph, I'm just showing that it is very important to make the decision, the right decision, in a very early stage of the project, because otherwise, let's say, the cost of changes, what you need to do if you have done something wrong, this will increase, the ratio is logarithmic. So if you need to go back and change something in production phase, I mean, if you're something already doing on board, you're making the installation, and then you realize that actually something went wrong in engineering stage, then, no yes, then it's a very big problem. So, and actually, this example demonstrates you that I'm not just, let's say, telling you this story, but also that our clients have noticed this, that we are doing something differently. And actually, this was already almost, approximately 5 years ago, but already that time, February 2018, Royal Caribbean, which is one of the biggest players in cruise business, they arranged a supplier conference where participated about 14,000 suppliers, their main suppliers. In total, Royal Caribbean, have 14,000 suppliers, but 234 suppliers from this total pool was invited for this conference. 8 of them received the award, and LTH received the innovation awards that you can see on this picture. So we are doing things in innovative ways. So how we are doing these projects? We are using point cloud-based design, but of course this we are using for larger projects. For small projects this does not make sense because this is simple and there is actually also no time for this. But this process, including the 3D scanning, this allows us to do very precise engineering, and as a next step from the engineering you can plan the project very accurately. Buy the materials with minimum required spares, the amount of spare, plus you can plan your amount of workers very precisely. Yes. So what kind of design services LTH is providing? We can start from the feasibility study. For the larger projects, actually, we already in the feasibility study, we include 3D laser scanning, which is this point cloud. And of course, we are able to prepare all the basic design and detailed design drawings. For some these tasks or disciplines, here is the list of disciplines that we can do: ship theory, structural, piping, etc. For some specific tasks, we are using also our partners. But of course, we are supervising what they are doing, and we are working like let's say, one family. How our design can create an added value? Because there is always discussion why your design budget is so big. But then I'm always telling to the clients that if you put €1 to the engineering, then actually this will earn you back €3 from installation side. This is like a thumb of rule. Of course, you can, let's say, put endless money to the design, but on certain, let's say, level, you need to invest money for the engineering because this actually saves you money. So you should not look the cost of engineering like separately. You need to look what is the total, project cost, engineering plus installation. So there is no point to argue with that reduce the engineering cost, then let's say your price is better. Because if you reduce the engineering price, then actually we are not able to do the project with the same money. Actually, we need to increase the installation budget. And actually, here is one example of bulkhead penetrations where we are normally doing final element analysis. So, most of you can think that, if you are considering the big cruise ship, 300 meters long, 40 meters wide, 17, 19 decks, and you want to cut, let's say 400 diameter hole in one of the transversal bulkhead in machinery room, what can happen? Because it's made of steel, the ship, and it's so big. But actually what can happen in reality, that this bulkhead can buckle elastically locally. And what this will cost you if you need to fix this later? compared to the analysis that one of your engineer can do. This analysis was done, this just took 1 day, but compared to the cost, if something happens on board, then actually this cost is nothing. And if you have done already your design model in 3D, then actually you can create quite fast this such analysis. So the next example actually how the design can help you is that we had a project on board and there was a need, it's the urgent need to make the cutout to the ship longitudinal bulkhead. So, but it's not so easy to do. I mean, from technical side, I mean, it's very easy to draw this drawing, make this drawing, 3 lines, and you are just taking plasma cutter or whatever on board and make this so. But as it is longitudinal bulkhead, then this bulkhead can elastically buckle, or these cracks in these corners will appear very fast. So you need to do this cutout very properly. You need to prepare the surface, make this cutting in a proper way. And there was a need actually to get this approval within 1 day, because otherwise our workers, there was no possibility to proceed with the works that they should do. So, and how to receive this approval from DNV, who was the Crash Society. It's very tricky, I mean, because this approval process can take like 30 days. So what we did, we made this drawing fast, and also we prepared like a grinding manual, so how you need to prepare the surfaces after this cutout is done. So I don't know, this took something like half day. Then I submitted this documents to DNV, also told them that it's an urgent need, and after 1 hour I received a call from DNV. And they asked me who prepared this grinding manual, because this is totally another level, and it seems that you know what you are doing. Then I actually mentioned him the name of one of our engineers, who is our head of design, and actually said, okay, I know this person. He's a doctoral degree naval architect. And he told me, okay, you need this urgently, but 1 hour is okay, because I need time to prepare the approval document. Then I said, of course, we can wait this 1 hour, no need to do it faster. So this demonstrates if you have the competence and if you have good engineers, then actually you can achieve a lot. And here is one of the next example. One of Ro ship owner called us because they had a huge issue in one of the marine diesel oil storage tank. The problem was that there was cracks appearing in the bottom plate of this tank. They have tried to repair this already several times, but crack again coming back. And they was in contact with the shipyard because there was a plan that after 2 weeks or something the ship will go to the dry dock. And the money that the shipyard asked, it was something close to 1 million to repair this issue. But for ship owner, 1 million is very big money. And actually there was no, the shipyard didn't give any guarantee that this will fix the issue. So you are paying 1 million, but actually don't know if this will fix the issue or the same will come back. So what they did, they ordered the final element analysis from us. This cost them something like, I don't know, 10,000, 15,000. And this analysis clearly showed that actually there is no need for such a major conversion. And by the end of the day, this work cost to the owner less than 10,000 euro. And now this ship has been in operating after this dry dock services more than, already close to 5 years, and no such issues have appeared again. So this also shows it is wise to invest the money for the design. And also one more example. There was, this is a cruise ship deck structure number 1. Maybe this is a little bit familiar for Sven from Forest Ship. What was the problem there? The problem there was that under this deck 1, there was a cofferdam structure, But this cofferdam structure, as you can see on the picture, this was like locally deformed. And actually, the ship owner didn't know what is the problem, why it's deformed. But also dry dock was coming, and they wanted to repair this deck. But they didn't want to do this without investigating what is the root cause of this, because otherwise you will just replace the steel, but this can come back very soon. And you have also, as you can see on the picture, cabins installed on top of this deck. So it's a major conversion to replace the steel, because also this interior part is involved. And also ship owner contacted with us. They knew that we have a very good competence in terms of structural analysis, and this was actually the main reason why this work was given to us. Because first we made an analysis and we showed them exactly what has been happened and how to fix it. What is also, let's say, one of the knowledge that the LTH has is that we can also make the analysis for exhaust gas, if we're talking about the exhaust gas system, I mean, for anchorage points and vibration mounts. And also we can calculate, dimension, the exhaust gas bellows. Also the ship owner knew that we have this competence. And what was the problem looking from the ship owner side is that they had a very specific bellow installed on exhaust gas system. The ship was quite old, 20 plus years. And actually the supplier who delivered this expansion joint in new build, this company was not anymore in the market. And the size of this bellow was so big that to transport this bellow to the installation location, this was more or less mission impossible, because you need to destroy the ship to be able to bring this to the installation location. But how to do this project if you need to cut the bellow? And in the world, believe me, ship owner was searching the supplier, it's already something like 1 year, let's say, to find the supplier who can produce this bellow in pieces and you can assemble this on board. And actually LTH Baas was the only company in the world who was able to do the proper engineering to build this, of course using subcontractors, to build this bellow in workshop, in pieces, assemble on board with our own workers, LTH workers, do the commissioning, and this bellow is now have been working already about something like 2 years on board without no issues, and now we are doing the same work for 2 sister ships. But this also demonstrates what actually you can do if you know what you are doing, if you have a very high competence in-house, and also the owner trusts you. What we are also maybe doing differently compared to our competitors is that if you're talking about large projects, scrubber projects, then there are hundreds of meters, if not kilometers, of GRE piping, which is like, let's say, like plastic pipes, let's say. But what makes it challenging is that, let's say, if something will happen, this pipe, then it will happen very fast. There will be like explosion. And as normally these pipes are huge, it can be up to TN 1000, the diameter. So just imagine if something will happen with this pipe and the water comes out from this pipe. So actually this can create very big damages. And there are actually some cases on board cruise ships where the cost of the damage that such pipe failure caused, it was more than 1 million. But what we are doing, we are always doing the final element analysis for these piping systems. That helps us to design a proper supporting system for these pipes. And actually now we are in contact with several cruise liners who are asking repair works. These projects what was not done by LTH to fix the problems. And there is actually, we are receiving more than we can do, let's say. And here you can see some good examples that demonstrate if this design, and also let's say the installation on board is done in not a proper way, let's say. So, but of course, I don't know, maybe it's, for professional, actually, it's already obvious if you see these pictures that these supports are like chicken legs. This cannot be last, actually. But still, I would say like 80-90% of our competitors, in some reason, we are still installing such supports. So, but what is LTH goal? Actually, LTH goal is to start to develop our own products. So it means that ship owner will contact us and they have a bigger problem that is, let's say, not only with one ship, but maybe a series of ships, and there is needed some kind of solution. And here, this is one of example. So on board this cruise ship, and there was actually more cruise ship in the same series, was installed scrubber, and after this scrubber installation, because the light weight was increased significantly, and this ship's stability condition was already close to the limit before this scrubber project, then there was need to do something with ship stability, talking more precisely to do something with damage stability. And for that what we did, together with the ship owner, we developed the concept of downfloating catches. And this allowed, let's say, if there is a damage, the collision or grounding, then you can lead the water that is in your machinery room to the double bottom, or from the double bottom to the machinery room. That helps you to improve the damage stability because the center of gravity will be reduced, so the ship will not, collapse. But what was also, let's say, the important terms, if we started this project, was the project cost. Because for the such previous projects, because the stabilities, there's several, quite often there is a problem, especially if the ships are old, that you need to do something to improve the stability. And the cost to improve the stability for the previous project, this was something about, let's say, 1 million. To increase this draft 1 centimeter. And for this project, there was need to increase it something like 5 centimeters or something like this. And the owner didn't have money to do this. But together with the owner, we developed the concept. We approved this with DNV, what you can see also here. All these spot tests, this was also approved by Malta's flag, which is actually not so easy to get approval for Malta's flag, especially when you're dealing with ship stability. But by the end of the day, we was able to do this project 5 times cheaper way. So this was significant cost saving from looking from ship owner side. And actually also LTH was the only company who was interested to develop such a product together with the ship owner. Because all other, they said that you have MacGregor, you can do this in a traditional way, of course the price is high, but no, this is what you need to do. What is the point to develop the concept to make the new product? Yes, but looking from ship owner side, as I said, there was a very big advantage. And last but not least, I would like to bring also your attention to one of the projects that we are having at the moment. This is HEMOS project. This HEMOS means Holistic Energy Management Optimization System. LTH received EU fund grant from Horizon Europe to do this project together with a consortium of companies. So we are leaders, this is our idea, but in this consortium there is one equipment provider from Sweden, Inepact, also university from Italy, Napoli University is involved, and we have also for the paperworks Baltic Innovation Agency who is located in Tartu. And what is the, let's say, the goal of this project is to make like a digital twin of ship's energy system. To investigate, let's say, mainly the waste heat, how to use the waste heat. And this digital twin allows us to test. So if you change one parameter, then actually you can see what will happen with the other parameters. And sometimes what our, let's say, research so far shows that just changing some parameters and also the way how you're operating the ship's energy system, you can say have 1-2% energy savings already just to optimize the system without adding any equipment. So, but what is our goal? Our goal is to allow ship owners to save up to 14%. And our analyses are showing that actually it is possible, not for all type of ships, but for some it's definitely possible. And at the moment we are in the stage where, let's say, this theoretical research is more or less completed, and we are entering to the installation phase, let's say. We are starting to plan this, selecting the final, let's say, exactly what equipment we will use for this ship. This is one of Royal Caribbean ship. And I believe next year we will have already like full-scale test results from this project. So that's it. If you have questions, then I'm pleased to answer to your questions. So in Estonian or in English.